Today I shall continue my task of building our pulley. Today we're actually going to be attempting the assembly. Now, something I forgot to do, we'll make the assembly for now. We'll just go build one right now. What we should really talk about is we forgot something important on the on this part. So actually open that right now. Open it right now. Open the base. I forgot to add a very important part to this, and that is I need to add an axis to these to the hole here. Why? Because we have a problem with that if we don't have one. So I need to go here to sketch 5, show it, and I need to select. Let's just do. Unfortunately, I'll have to do this one. Yeah, point to face. Faces move, so this is a method that I really don't feel comfortable using, but I can't figure out another way to do it. So that's what we have to do right now. Put that on there. Hide this guy. I'll keep the axis shown and save it. So if we go back to our assembly, we will have to rebuild it to see that there's now an axis. So the first thing you have to notice is there's an F right here next to the name. We want to make it float. So now this thing now can move around. Without it, if we go back to putting the back to before saying float on it. Well, if we go back to fix, right, bring that to F, we can't move it. So we have to make sure it's on float. Apparently cannot undo those, so just keep that in mind. The right plane of the assembly is there. We want it to be coincident with the right plane of that. So this thing can move up and down and everything. Front plane and front plane should be, I think parallel works. Parallel does not work. I need to make it coincident. Front plane, front plane. Make those coincident. And top plane to top plane can be coincident. Okay, I'll rebuild that. I don't want that. I want the informational summary. We have now, this thing is now fixed in place. Look down the corner here, it is fully defined. And now we can start adding more parts. Now, obviously this is a kind of the rough drawing of it. Kind of like the, just bring in all the parts. So we can kind of get a good idea what we have to adjust and what we have to make different. Now, obviously, I need to open up these guys here so we can adjust them. As you see, we can already tell that we have some little fun issues here. So, I want the axis of this and the axis of this to be coincident for now, just so we can get a good idea about how far off we are. We're actually pretty dead center of what we have to be. Okay, so we need to increase the distance between these two parts here. That is going to be a little bit of fun because we would also have to change the distance of these two, the cut sketches. So this thing right now is pretty wonky right now. It doesn't really do much outside of spin around. The pin here, we go to the pin. If we select its axis and the axis, I'm going to select the axis of this, of the actual base, make that coincident as well. We can determine if we made the hole the right size. By the looks of it, we kind of guessed correctly. Yeah, it's exactly what it is, so we have to adjust that a little bit. This is definitely not the right size. So I'm actually just going to make this bigger and this bigger here. And in order to do that, we have to open them. And we can adjust the size accordingly by going into the sketch here and changing this diameter here. So instead of 0.4, what is the current size of the wheel's inner diameter? That's what I want to know. What's the current size of the wheel's inner diameter, right? The inner diameter of the wheel right now is 1/2 inch. So instead of 0.4, let's make it, let's make this instead of 0.4, which is, where exactly? It's going all over the place. 0.4, we'll make it 0.47, 0.47 instead, because this is what the pulley is going to be rotating around. So we save that. We go back into our thing here. Yep, we can see that it is in fact right around the correct diameter. It's 0.3 lower, which is good for this. This, on the other hand, the hole is actually going to be a little smaller, but we're just going to go fix the major chunk right now, the major issues. Going to the front plane real quick, going over to, actually we have to go to the top plane actually to do this one. To choose this one here, we change this to 0.64. And you'll notice already that we're running into issues. You'll notice that there's kind of a lip here now. Now if we go back, Control Z, you'll see there's nothing there. But if we go forward on it, go back to what we did here, you'll notice there's a little bit of a problem. Right, now we have another issue here. So that we have to go to our cut sketch, edit the sketch there, and then bring this up to plus 0.004. That's wrong. We messed that up already, and then build that, and now it's flat again. So now, if we say rebuild and then save it, we can go here, yeah, which is fine, we'll accept it, and we can determine, and now it floats. So what we can do now with the wheel is find out what plane this is. This is the top plane. Top plane and the right plane of the base I'll make coincident to put it right smack in the middle. So now this thing will roll around and stuff because there's one. To fix it, we're going to have to do like top plane to top plane parallel. Actually cancel because we chose the wrong plane. It's going to be, it would be right plane to top plane parallel. And as you see, the pulley is now fixed. So now we need the pulley pin. So the pulley pin is going to be a little bit of fun because as you see here, we're going to have to adjust it so it actually goes all the way through. So the question is, how long do we have to make it? This we really don't need to put like a tolerance or anything because we'll fit either way. We want it to be flush. So we measure this distance to this distance is a whole 0.84. So that's the length that we're going to have to add onto this thing. So we have to go edit the sketch. Now, if we were smart about this, we would have actually done a different method of building the thing, and that is measuring the distance from this to that. Unfortunately, we cannot. We actually can here if we do it this way. I don't want to know the overall length, I just want to know this. So if we go 0.84 as the length, save that, we go back here, and it's fine, and drag this over here, we can see it pretty much makes it. Now obviously this needs to be adjusted as well, the size needs to be adjusted. I honestly like the height here. We could lower it in theory we could actually lower it, but I think the height is fine. Now looking at it, might actually lower it. I'll think about it. But what we have to do is adjust the size. So if we take our measure tool, select this face, we'll find that it is, I think, 1 1/8 inches in diameter, correct? Are we correct about that? Let's check it. No, we're completely wrong. It's 0.47. I guess we selected the wrong thing. So we're going to edit these. So this will become, I'm actually make it 0.49. Actually, let's make it 0.5 actually. There we go. I mean, that's a massive size difference now. Like, that's pretty much fit that in. So the pulley pin might actually move around as well, which is okay. I think that's fine. So actually right now we're going to right plane to top plane. We're going to make parallel so it doesn't rotate. And all we have is one direction we have to worry about. Obviously this is not the last part. The last part is actually putting on the end cap here. Well, I'm going to have to make an end cap. But what we need to do is determine the distance between this and that. So a cool trick is you go to the plane you want, in this case the right plane, and then the top plane of this, right? And if we go, I want to mate these two. We're going to be using a different mate that I haven't used, at least haven't shown people it yet. And that's the distance mate. We use the distance mate, we hit OK and stuff, obviously. But now we need to know how far this is. So if we go here and here, we could determine this number here. So 1 inch and 1 inch and well, whatever, 1 inch, 0.3, 1.3 inches, 1.1.3 inches, whatever the heck it is. That's the distance that we need to worry about. Go to our distance mate. We can edit the feature here, and we could select the subtraction of minus 1.13. Now the mate is complete, and it's inside there, perfectly in place, perfectly in line of what we have. What we really should have done is, let's go back. I want to change this distance mate here to be more of a flat number, because it's be a bit much easier to type in, because that decimal place of the 0.13 isn't completely accurate, because it's only adds a 2-place decimal. There isn't a third one. So now we notice that it's 0.08, 1.08. So we can minus that, subtract 1.08 instead, and it actually becomes flush this time, because I'm pretty sure this wasn't flush at all. So that's how you basically do the assembly. This is the pulley. It doesn't really look too much like my old one. We're going to save it. Yeah, save all of them. We're going to call this pulley. V2, actually. That'd be the assembly there. So that was a simple, very simple to assemble part and everything, but we need to have some form of retaining pin here. Now that requires a little more engineering, a little more involvement with that, because there's multiple ways we could do it. We could, after constructing the thing, we could have already like a hole that's already put in there, and we just put a tap in there, and then we have the other half be just like a pin that would fit in there, but we have a die for that and make it like a little screw. Or the other method is kind of friction fitting it in, just put it in there, should fit fine. Of course, I need to remember the exact decimal places for that, but we'll figure it out. So we'll probably do that next episode. Hope you enjoyed today's video, and see you next time.